Welcome to Echo 204, Study Session 6. Some economic applications of the rules. Marginal cost and marginal revenue. In general, the derivative of any total function gives its marginal function. For example, marginal cost is the derivative of total cost. That is, MC of Q equals DTC of Q divided by DQ, and MR of Q equals DTQ of Q divided by DQ. E.g., given a short-run total cost function TC equals Q3 minus 4Q squared plus 10Q plus 75. The marginal cost function is the derivative of the total cost function. MC of Q equals DTC by DQ equals 3Q squared minus 8Q plus 10. We would observe that the constant, which represents the fixed cost, does not affect the derivative because the derivative of a constant is zero. This fact provides the mathematical explanation of the well-known economic principle that fixed cost of a firm does not affect its marginal cost. Finding marginal revenue function from average revenue function. Consider an average revenue function in the form AR equals 15 minus Q. We can find the marginal revenue function only after we have obtained the total revenue function. TR of Q equals AR of Q. TR of Q equals 15 minus Q in bracket times Q. TR of Q equals 15Q minus Q squared. We can then take the derivative of TR of Q with respect to Q to get the marginal revenue function. MR of Q equals DTR of Q by DQ, which equals 15 minus 2Q. The same procedure applies to deriving the marginal cost function from the average cost function. First, obtain the total cost by multiplying the average cost by quantity, that is, TC equals AC times Q. Then take the MC equals DTC by DQ. Observe the similarities and differences between the average revenue function and the marginal revenue function derived from it. The two functions have the same vertical intercept, but the slope of the marginal function is twice that of the average revenue function. This is the general result whenever we have a linear average revenue function. Graph 7. Relationship between average revenue and marginal revenue in an imperfect market arrangement. For a firm in a perfectly competitive market arrangement, the total revenue function is linear, hence the marginal revenue and the average revenue functions coincide at a constant. Example: consider a perfectly competitive firm with a total revenue function of the form TR of Q equals 32Q. Find the AR and MR. Solution: AR equals TR divided by Q. AR equals 32Q divided by Q, which is equal to 32. MR equals DTR by DQ, which equals to 32. Therefore, for a firm in a perfect market arrangement, MR equals AR equals P. Graph 8. Relationship between marginal cost and average cost functions. As an economic application of the quotient rule, let us consider the rate of change of average cost when output varies. Given a total cost function TC equals C of Q, The average cost function will be a quotient of two functions of Q, since AC equals TC over Q equals C of Q over Q, as long as Q is greater than 0. Therefore, the rate of change of AC with respect to Q can be found by differentiating AC. dAC over dQ equals dCQ divided by Q by dQ, which equals C prime of Q times Q minus C prime of Q times 1 divided by Q squared. We can split the fraction and have C prime of Q times Q divided by Q squared minus C prime of Q times 1 divided by Q squared. So we have C prime of Q divided by Q minus C prime of Q divided by Q squared, all in bracket, factorize. So we have 1 over Q times C prime of Q minus C of Q divided by Q in bracket, where C prime of Q equals MC and C of Q divided by Q equals AC. It then follows that dAC by dQ, which is greater than, equal to, or less than 0 if C prime of Q greater than, equal to, or less than C of Q divided by Q. What this means is that the slope of AC is positive when MC is greater than AC. The slope of AC is 0 when MC equals 0, and the slope of AC is negative when MC is less than AC. Example 1. Given that total cost function TC equals Q to power 3 minus 8Q to power 2 plus 15Q plus 30, write out a variable cost function. Find the derivative of VC function and give the economic meaning of that derivative. Solution: TC equals VC plus FC. VC equals Q to power 3 minus 8Q to power 2 plus 15Q. dVC by dQ equals 3Q squared minus 16Q plus 15. The economic meaning of the derivative above is the marginal cost. Remember, we said that the fixed cost does not affect the marginal cost. Therefore, the derivative of both the total cost and variable cost gives the marginal cost. Example 2. Given average cost function AC equals 2Q squared minus 4Q plus 214, find the marginal cost function. Is the given function more appropriate as a long run or a short run function? Why? Solution: TC equals AC times Q. TC equals 2Q squared minus 4Q plus 214, all in bracket, times Q. TC equals 2Q to power 3 minus 4Q to power 2 plus 214Q. MC equals dTC divided by dQ equals 6Q squared minus 8Q plus 214. The function is more appropriate as a long run function because the total cost function does not have any fixed component, which is characteristic of the long run. Note, in the long run, all factors of production are variable as well as the associated cost. Therefore, in the long run, fixed cost equals 0 and variable cost is equal to total cost. Example 3. AR equals 60 minus 5Q. A. Find the total revenue Comparing the AR and the MC functions, what can you say about the relative slopes? Solution. TC equals, I take that again, 1, 2. Solution. A. TR equals AR times Q. TR equals 60 minus Q in bracket times Q. TR equals 60Q minus 5Q squared. MR equals DTR by DQ, which equals 60 minus 10Q. B. The slope of the marginal function 10 of the average revenue function. This is the end of study session 6. Thanks for listening.